Hi, my name is Rowan Uy, and today my team and I will present an analysis of New Zealand's greenhouse gas emission. Our focus is to identify trends and key drivers of emissions in New Zealand. The purpose of this study is to provide insights for effective policies and sustainable practices to reduce emissions, protect ecosystems, and secure a stable future. This analysis supports New Zealand's climate goals while contributing to global sustainability efforts. Let's dive deeper into key issues and objectives. But before that, our background study is about a greenhouse gas emission from human activities like energy production, transportation, and agriculture are intensifying global warming. This leads to severe climate impacts, ecological damage, and health risk, such as extreme weather, biodiversity loss, and increased air pollution. These emissions also cause socio-economic challenges, including reduced agricultural productivity and rising costs for disaster recovery and healthcare. To address these issues, we need targeted mitigation strategies like renewable energy adoption and sustainable practices to reduce emissions and build a more resilient future. As we begin, let's outline the key problems surrounding greenhouse gas emissions. Firstly, we face rising emissions with concentrations continuing to increase, significantly impacting sectors like agriculture, transportation, and public health. Secondly, climate disruptions caused by unpredictable weather patterns are leading to reduced crop yields, transportation challenges, and heightened health vulnerabilities. Lastly, there is a lack of insights, a gap in clear statistical guidance for crafting effective policies to address these issues. These challenges form the foundation of our study and underline the urgency of taking action. Our objective includes examine statistical data to uncover trends in greenhouse gases emission, determine the primary drivers behind these emissions over time, evaluate the sectoral impacts of emissions, especially on agriculture, transportation, and public health, provide actionable insights to inform policy making and sustainable development efforts. Lastly, support stakeholders, including policymakers and environmental organizations, in addressing climate change through evidence based strategies. With these objectives in mind, let's explore who is most affected by this issue. The impact of greenhouse gas emission extends across multiple sectors. In agriculture, farmers face financial strains due to harsh weather conditions, which reduce crops yield and livestock health, jeopardizing food security and causing price volatility. In transportation, commuters and freight operators encounter hazardous conditions, leading to delays, accidents, and increased infrastructure repair costs. Finally, in health, vulnerable populations such as the elderly and the children are greater at risk of respiratory diseases, vector-borne illnesses, and rising healthcare expenses. These groups illustrate the widespread consequences of climate change, making it vital to address these challenges effectively.
So today I'll be talking about the literature review. So I'll be talking one of the main part in the literature review, which is statistical approach in previous work. So the first thing that we use was time series and regression analysis. We analyze seasonal cycles, long-term trends, and forecast emission from 2007 to 2022. We also identify key drivers of emission using regression models, including energy, fertilizer, and livestock activity. Next, we use input-output analysis, where we assess how emission in one sector influence emission in other sectors. We evaluate indirect emissions contribution through the transfer of goods, services across supply chains. Next is we use emission factor models, where we use standardized coefficients to estimate emissions for specific activities like fuel combustions or agriculture practices.
So today I'll be presenting an analysis of greenhouse gas emissions, focusing on their distribution by sector, household categories, and regions. So we'll be using data visualizations like pie charts, line plots, and bar charts. So for my first part is by sector. So sector-wise emissions show that agriculture has the largest contributor, which is 18.6 of total emissions due to activities like livestock, grazing, fertilizer use. Other sectors like primary industries and forestry also contribute significantly, while smallest sectors like mining and construction have minimal impact. So this is my pie chart. Next is by household. Transport stands out as the dominant category here, particularly in urban areas, with its peak between 2015 to 2016 before stabilizing in years. Meanwhile, heating and cooling as well as household categories remain consistent but minor contributors. So lastly is by region. The regional data highlights stark disparities in emissions. So certain regions have much higher averages, emphasizing the need for region-specific strategies to address these emissions effectively. So this is my line point. Lastly, I would like to conclude by saying agriculture is the largest contributor to emissions at 18.6%. So regional disparities show that in industrialized regions like Waikato, like I mentioned here, have the highest emissions, while areas like Nelson emit less. So to address this, we need targeted policies that improve energy efficiency in high emission regions and support sustainable development in low emissions areas. Additionally, sectors like agriculture, manufacturing, and urban transport require cleaner energy solutions to reduce their carbon footprint. A comprehensive multi-perspective approach is essential for effectively reducing emissions across sectors and regions. So that's all from me. Thank you.
Now let's dive into the methods used in our analysis. This section highlights the statistical and analytical approaches we employed to uncover key insights from our data. Our methodology relied on 5 key techniques, each tailored to address specific aspects of the dataset. First, we used descriptive statistics to calculate the mean, median, mode, standard deviation, and range of gas emission values. This provided a functional understanding to how emissions are distributed across sectors and regions. Next, we applied data transformation or feature engineering. By breaking down categorical variables like exit descriptor and household category into unique binary descriptors, we were able to filter and analyze specific categories more effectively. The third method involved frequency counts, where we counted occurrences of significant categories, such as household activities and industrial sectors, to identify the most impactful contributors to greenhouse gas emissions. We then implemented data filtering and aggregation to focus our analysis on key categories. This ensured that we captured critical insights without losing important threads within subcategories. Finally, we used visualizations, including pie charts, line graphs, and bar charts to present our findings clearly. These visual aids help us highlight patterns, trends, and disparities in the data. Our approach to data analysis was structured around 3 components. First, we used binary encoding to transform categorical variables into a format that allowed for detailed and precise analysis. Second, through descriptive statistics, we summarized the distribution of emissions across different sectors and regions, giving us a deeper understanding of the data structure. Finally, we used visualizations, which brought the data to life by representing sectorial contributions and regional disparity through charts and graphs. We were able to present our insight in a way that's easy to interpret and understand. In summary, these methods provided a comprehensive framework for analyzing greenhouse gas emissions. By combining statistical techniques with data visualization, we were able to identify trends, understand drivers of emissions, and provide actionable insights for addressing climate changes.
Now let's dive into the results and discussions highlighting key insights from data visualizations presented on the next slide. So first, the pie chart shows the sectorial contributions to greenhouse gas emissions in 2022. Agriculture emerges as the largest contributor, accounting for 18.6% of total emissions. This is primarily driven by practices like livestock farming, fertilizer use, and deforestation. These findings emphasize the need for targeted interventions in the agricultural sector to reduce the emissions. Next, the line plot over here tracks the household emissions over time. The urban transport emissions are particularly significant, peaking around 2015 to 2016 before stabilizing. This stabilization indicates some progress, but also underscores the continued need for sustainable urban mobility solutions, such as the promotion of public transportation and electric vehicles. Lastly, the bar chart illustrates the regional disparities in emissions. Hokkaido, Canterbury, and Auckland exhibit the highest average emissions. Hokkaido's emissions are largely driven by agricultural activities, while Auckland's high population and industrial development plays a significant role. These regional insights highlight the importance and localized policies to address specific emission drivers. Overall, these visualizations provide a comprehensive view of emission trends by sector, time, and region. They underline agriculture and urban transport as key contributors, and Hokkaido and Canterbury and Auckland as critical regions for intervention. These findings pave the way for targeted policies to reduce greenhouse gas emissions effectively.
All right. Now I will pass to Roshan to explain the limitations of the study. Thank you.
All right. So next I'll be talking about the limitation and future of study. The first thing is we need to identify the limitation. So we have 3 limitations, which is redundancy in binary encoding. So binary encoding of categorical features such as ANZ descriptor leads to high dimensional data and potential redundancy. Next is impact of outliers. We have learned outliers so many times, right? So outliers influence calculation like mean and standard deviations, skewing the interpretation of trends. So basically, outliers is something like a data is found from the normal distribution of data. That's what I understand what outliers is. And is plurality of data and lack of consistency over years. So broad activities categories like forestry and logging obscure specific emission rivers within industries and households. So after knowing all these limitations and all, we come with a future direction. So how can we improve all this limitation you can see? The first thing will be enhanced statistical techniques. We employ robust techniques to manage outliers in computation of mean and range effectively. Hence, we add contextual variables and data interpretation. For example, we add social economic factors, credit, regulations, technological changes to provide broader emission content. Next, improve data visualization, where we integrate modern visualization tools such as interactive dashboards for clearer exploration of complex data sets. So the conclusion is, from this study, all of us come with conclusion that this study offers a true analysis of New Zealand GHG emissions, providing valuable insight that can guide policymakers and stakeholders in creating effective climate strategies. The study also recommends further research into international comparisons and the impact of renewable energy on emission reduction for a more comprehensive understanding of global climate dynamics. So that's all for me. Thank you so much.